Hi folks, welcome back to 8.8, and in this video we're going to talk about the unit vector, which is a special kind of vector. All right, so a unit vector is just a vector that has a magnitude of 1, okay? So if you recall from the previous video, we actually had an example where we had a vector v. It was kind of weird with fractions, but when we calculated the magnitude, we got 1, right? So example 6 here is actually an example of a unit vector, okay? So anytime we have a vector with length 1, it is considered a unit vector, all right? Now there are two special unit vectors, okay? And in particular, there's one that goes in the horizontal direction and one that goes in the vertical direction, okay? And so if we take the horizontal one, so the horizontal unit vector, all right? And then we also have a vertical unit vector. Right? The horizontal unit vector, we often call I. Now, this is not the same I as the imaginary I, okay? But this rather is a vector that is horizontal length 1 and vertical length 0, okay? So we go over 1, but we don't go up or down any. And then the vertical unit vector, we use the letter J. All right, so I think this unit with the U's and the V's and the I's and the J's, it's so important that we keep our variables nice and neat, all right? So I is the horizontal one, but J is the vertical one, so we don't go across any, but we do go up 1 unit, okay? So anytime I see the letter I, I'm thinking, oh, it's just 1 unit up in the 1 unit over in the horizontal direction, and anytime I see J, I'm thinking it's just 1 unit up in the vertical direction. All right, so let's take a look at example 7 here. Given A equals 5i plus j and B equals 4i minus 7j, find A minus 3b as a linear combination, okay? And so this is very similar to if we were to write A in standard form, we would have 5, 1, right? Because we go over 5 and up 1. And if we were to write B in standard form, we would get 4 over and 7 down. Okay, so it's not any different than the stuff we looked at before. Now, if we're looking to find A minus 3B, that's the same as 5i plus j. Okay, so this is our A minus 3 times B. Okay, and our B is simply our 4 minus 7j. Okay, and so now it looks a lot like the problems we started off in some of the earlier videos where we're just going to do some arithmetic. So we get 5i plus j minus 12i, and being careful here, we don't have minus 21j, we have plus 21j. We combine our like terms, we get negative 7i plus 22j. And that is the linear combination of our vectors A minus 3b, okay? All right, now, to find a unit vector, all right, so if we're actually trying to find a unit vector, we just use the following formula. We take a vector and we divide it by its magnitude, okay? And what you end up with is you end up with a vector that's in the same direction as your original vector, but it has a magnitude of 1, okay? So if A equals 5, negative 4, find the unit vector for A, then we're going to draw the original and the unit vector on the grid just to visualize it, okay? So let's do a little bit of work. We want to find our unit vector. We're going to take A and we're going to divide it by the magnitude of A. So we have lots of space. So we've got 5, comma, -4. And then our a, how do we find that again? Well, we just take the horizontal component, we square it, we add it to the vertical component squared, and we take the square root of the whole thing so that we can get effectively the hypotenuse and not just our hypotenuse squared. We do a little bit of arithmetic. 5 squared gives us 25 plus 16. So 25 plus 16 gives us 41. I know that's not a nice number, so I'm just going to leave it that way. And our unit vector will be 5 over root 41, comma, -4 over root 41. I don't need you to rationalize this. This is totally fine. Here's our unit vector, okay? And if we were to find the magnitude, we would find that it has a magnitude of 1, all right? But let's draw our original vector in one color. And let's go with maybe the purple. Okay, so in the purple, I'm going to go ahead and I'm going to draw the original vector. So 5 over and down 4 means that my original vector looks something like this. Okay. Now, my unit vector, all right, and let's make the unit vector maybe in this green color over here. Our unit vector, this vector, is going to be in the same direction, but it's going to have a magnitude of 1, okay? So if I were to turn those into decimals, I might find that it ends up something like this. And that little green arrow has a length of 1, but it is exactly in the same direction as the purple vector. Okay, so that's what we mean when we say unit vector. We basically take something that has some length, in this case, root 41, and we scale it down so that it has a length of 1. All right, and that's it for unit vectors, my friends. Come on back in the next video. We're going to talk about something called dot product and how we find the angle between two vectors.